Hi, welcome to this video on physical quantities, units and measurements, what you need to know for O-level physics. So in this video, I'll be covering what you need to know on this chapter when you sit for your O-level physics. So let's get started. So in this video, I want to go through what you need to know for each chapter in physics. And for this video, we'll be focusing on the chapter physical quantities, units and measurements. Okay, and to make sure that it is relevant to your O-level physics exam, I am going to base this summary on the syllabus. So here is the syllabus, okay, for pure physics, O-level pure physics. And this is what you need to know for the chapter on physical quantities, units, and measurements. So let's go through them line by line. So in the first portion, you need to know that candidates should be able to understand that all physical quantities consist of a numerical magnitude and a unit. Okay, so usually they won't ask any questions regarding this, asking you to say that, oh, physical quantities, you need to have both numerical units, you need to have units as well as magnitude, but rather throughout your entire paper, whenever you write a value for whichever physical quantity, you make sure that you have both the magnitude, which is the number, plus its units. So in other words, right, let me give you an example. So for example, if I'm going to find things such as velocity, okay, so if I'm going to find velocity, then and I know that the velocity is 3.0 meters 3.0, I need to write both the magnitude, which is this number here, as well as the units, which in this case for velocity it will be meter per second. All right. Okay, so basically this part is just reminding us that for all the physical quantities, whenever we are writing a value for physical quantities, remember we need to write both the magnitude, which is a value, as well as the units, because without a unit it is meaningless. Okay, next, recall the following base quantities and their units. So these are some of the base quantities, like mass is in kg, length is in meters, time is in seconds, current is in amperes, temperature is in Kelvin, and amount of substance is in moles. Okay, so this one basically just know it. Okay, then part C, you need to know that the following prefixes and their symbols. Okay, so this one is important. So part C, okay, reason is because sometimes they give us let me erase this first. So what does part C requires us to know? Well, it requires us to know that whenever I have nano refers to 10 to the power of minus 9. Okay, and then micro refers to 10 to the power of minus 6. Okay, and then milli, small m, refers to 10 to the power of minus 3. Centi is 10 to the power of minus 2. And deci is 10 to the power of minus 1. Okay, then we also have kilo, which is 10 to the power of 10 to the power of 3. Mega, capital M, 10 to the power of 6, and giga being 10 to the power of 9. Okay, then you'll be wondering, will they ask us what is nano, what is micro, what is milli for your exam? Usually no. Okay, but you need to know this because you need to do a certain conversion. So let me give you an example. For instance, they tell us, so in physics, right, we have formulas. So for example, we have formulas such as this. Okay, so I have current. Okay, so I have this formula, Q is equals to IT, and the formula for Q is the units for charge, which is Q, is coulombs. The units for I is in amperes, and the units for time is in seconds. So what if the question asks me to find charge given I is equals to 10 milliampere and T is equals to 5 seconds? Well, in order to find charge in coulombs, I need to change current to ampere. So in order to do so, I need to make use of my knowledge of these. Okay, I need to make use of my knowledge of these prefixes and what they represent. So I know since I current is equals to 10 milliampere, and milli refers to 10 to the power of minus 3. Therefore, I know that I is equals to 10 times 10 to the power of minus 3 ampere. Okay, so using Q equals to IT, I can now take 10 times 10 to the power of minus 3 times time, which is 5. All right, so that is the more common use of our knowledge of these prefixes in your O-level physics exam. Okay, then in part D, show an understanding of the order of magnitudes of the sizes of common objects ranging from typical atom to the Earth. So if you are looking at atoms, generally they are measured, their size or the length will be measured in terms of nanometers. Okay, then for Earth, it is very huge, right? So we will be using like mega and gigameters. Okay, or we can use kilometers as well. Okay, but it will be quite a big value. All right. Okay, next let's look at E. State what is meant by scalar and vector quantities and give common examples of each. Okay, so a scalar quantity is one that has scalar. It has both, it has only magnitude, it doesn't have direction. For a vector quantity, it is one that includes both magnitude and direction. Okay, so I do have a post on scalar and vector quantities, plus all the definitions that you need to know, or all the common definitions that you need to know for your O-level physics. So I will provide a link to it below so they can check them out. Okay, so so this part E says that you need to know the definition, or you need to know how to explain what is a scalar quantity, and you need to know how to explain what is a vector quantity, and you need to give examples. So examples of scalar quantities will include mass, time, distance, and so on. For vector quantities, it has both magnitude and direction. So some examples would include velocity, acceleration, force, and so on. Okay, part E, you need to add two vectors to determine a resultant by graphical method. So most school don't cover this portion in the chapter on physical quantities, units, and measurements. They usually cover it under the chapter on dynamics of forces. Okay, but for the syllabus, it is written here. So what does it mean is like if you have a vector, so maybe let me erase everything now. Okay, so okay. Okay, so let me erase it so that it will be easier for us to, so that I have the space to draw a diagram here. Okay, now, okay, I'm done. So let's look at part F, where they ask us to find or determine a resultant by graphical method. So to do so, we usually use the triangle method, right? So for the triangle method, so for example, I have a vector A here and a vector B here. Okay, so I will join them so that they point in one direction. Okay, and the resultant would be this one here. Okay, so this one is the resultant. So we usually use the triangle method to um add two vectors that are not in, they are not pointing in the same straight line. Okay, so you need to draw a triangle diagram. Okay, so if you have A and B, then the resultant will be here. If you have vectors like this, A, B, and C, notice they point and they complete the entire triangle. So I start from A, I go to B, and after C, I come back to A already. For this here, the resultant is equals to 0 because you end up at the same place as where you started, right? So therefore, resultant for A plus B plus C is equals to 0. But for this triangle here, we know that I start at A, I end at B. Okay, okay, and it is start here and here, so this is the resultant, which I label it as C. Okay, so you need to be able to draw the how to add, so you need to be able to add the two vectors, and usually to do so we'll draw a triangle. Okay, Then next, describe how to measure a variety of lengths with appropriate accuracy by means of tapes, rules, micrometers, and calipers. Okay, use a vernier scale as necessary. So you need to know how to use your ruler. Okay, remember a ruler measures to the nearest 0.1 cm. Then you need to know how to use a vernier calipers, which measures up to 0.01 cm, and you need to know how to use the micrometer screw gauge, or which measures up to 0.001 cm. Okay, for the micrometer as well as the vernier calipers, you also need to know how to read the zero error. Okay, zero error occurs when the zero of the vernier scale and the main scale are not in line with each other. For the micrometer, what happens is when the reading on the zero on the timbre and the zero on the main scale, when they are not aligned with each other, then you have a zero error. So if there's a zero error, we always subtract away the zero error to find the actual reading. Okay, so make sure you know how to use these instruments as well as the zero errors. Okay. Then next, for H, you need to know how to measure a short interval of time, including period of a simple pendulum with appropriate accuracy using stopwatch or appropriate instruments. So basically, just measuring the period. So next, what is a period? So a period is the time taken for a pendulum. So what is the period of a pendulum? Well, the period of the pendulum is the time taken for it to make one complete oscillation. So if I start counting from the equilibrium position, that means when it is vertical. Okay, okay, wait. This is A, B, C. Okay, so so you can calculate it from point A, point B, point C, or anywhere in between. Okay, doesn't matter. But the easiest will be either from point C, point A, or point B. So find one period, it means to go from A to B, back to A to C, and back to A. So in other words, right, it will cover all the positions that this pendulum will pass by, and in both directions. So in other words, right, you'll be wondering, hey, I go from A to B already. Why do I still need to go from B to A? Well, because from A to B is going from A to B. Then from B to A is coming back. Okay, so it is slightly different. So in other words, right, when we are looking at one period, right, it refers to the time taken for the pendulum to make one complete oscillation. Okay, and that would refer to rate moving through all the positions and in all the directions that it will move in. Okay, so if I count from A, that one period will be from A to B, back to A to C, then back to A. If I start from B, what would be one period? Well, it will be the time taken to go from B to A to C to A and back to B. Similarly, if I start from C, then one period, a period will be the time taken for it to go from C to A to B to A and back to C. Okay, right, and the time taken for one period is usually very small. Okay, so when we are doing experiments, right, we do not measure just one period. Okay, we will measure maybe 20 periods and then divide this time by 20 to find the time taken for one period. Why is this so? Well, this is because when we take the average, okay, when we divide it by 20, we actually reduce the amount of error in the reading. Remember, whenever we are taking readings involving time, there is something known as the response time, okay, human response time, which is around 0.3 seconds. Okay, can you imagine if one period is equals to 1 second, then your human response time will be around 30% of the um, of the reading, right? It's a 30%. It's a very big error. But if we were to take 20 periods, right? Find the time taken for 20 periods, okay? Or find the time taken for 20 complete oscillations and then divide this reading by 20 in order to find one period, then what we are doing is we are actually reducing the error. Okay, so the human response time error is now divided by 20, which reduce the amount of error in our reading. Okay. Okay, so with that, I've covered the portion on what you need to know for physical quantities, units, and measurements. Okay, for a lot of items, right, can just read through. What is key is know part B, know part C. So know what nano, micro, milli, centi, deci, kilo, mega, and giggle, what they represent. Okay, know the definition of scalar and vector quantities and give common examples. Make sure you know how to add two vectors together. Okay, in part G, know how to use your micrometer and your vernier calipers. I believe for using ruler and your measuring tape, it is intuitive by now. So make sure you know how to take the readings for the micrometers as well as the calipers, as well as how to read the zero errors for these two. Okay, finally for part H, I need you to know what is one period. One period is the time taken for one complete oscillation of the pendulum, and what is one complete oscillation. Okay, so with that, we have completed our the first chapter of physical quantities, units, and measurements. Okay, so I'll be going through other chapters as well. So do check out our other videos. So see you.